Hello and welcome to the mini test solving for the lecture 21 probabilities. Again, I apologize for the painstaking state of the video. It was a pain to listen to, and I won't judge you if you clicked off it, but here is the mini test for those of you who came to solve it, and for everyone else, let's get ahead into solving it. For the first task, we had a box of balls. We know that one ball is drawn, and our task was to list all the elementary outcomes, give the probabilities for all of them, and the probability of drawing a red ball. So I have made a set R and B, where R is red balls and B is blue balls. E1, E2, and E3 are red balls, so they're elements of the red set or red event, and E4 and E5 are the blue ball set events. Now for probability of individual elementary outcomes, since there's 5 balls, 5 outcomes, each has 1/5 at the start. And as for the probability of red, we just add these 3 together, so 1/5 plus 1/5 plus 1/5, or we just add 3 divided by 5, basically giving us 3 times 1/5, 3/5, which is the result for the C part of this question. For our second task, we have 18 students that like math, 12 that like physics, and intersection being 7, so 7 students that like both. Our task, so before that I drew a simple Venn diagram to help me solve it. First, let's see how many like only one subject, or each subject, so we take the difference between the listed number and the intersection, and we see that there's 11 students that like only math, 5 that like only physics, and 7 that like both. This way it's a lot easier to check how many students are in the class. So 11 plus 7 plus 5 is 23. We could have just added these two together and then subtracted 7 as the formula. And this will help us, well, we wouldn't have to do this first because probability of a student randomly liking math or physics is just this count divided by all of them. But for all of them, we could have used the formula, as I said, add these students with these students and subtract the intersection. It gives us the number of all students. But we did this before because we are good, diligent students. Anyway, the probability of a math student is 18 over 23, and probability of physics students is 12 over 23, which, if I'm not mistaken, I forgot to write it down. I think it's like 52% for physics, and like, what would that be, 75, 77, 78. This one's like something over 50, and this one's something over 75%. I'm not exactly sure on the precise numbers for that one. But yeah, this is enough for the result. Yes. Now for the conditional event, so there is an overlap between the two groups, we will use the formula with the overlap over math. So physics if math has certainly happened. I think that's what the task wanted from us. Anyway, so we take the probability of the intersection divided by the probability of a math, and we get 7 divided by 23 divided by 18 divided by 23. We could just take the count of the students, but let's do it the long way. It's 7 over 18, as it's the number of students here divided by the number of students here. And this is like, what, another 5 less, which is, what, 30-ish%. Anyway, this is the solution to the second task. For the third task, roll of a fair die, our event A is labeled as the roll greater than 4. So let's list all the elementary outcomes. Event A is a set comprised of a throw 5 and a throw 6 because it's greater than 4, not greater than or equal to 4. So we have elementary outcome 5 and elementary outcome 6. The probability of A is a count of set A divided by 6 because there's 6 sides on a dice or a die, and that's 2 divided by 6, it's 1/3, and that's the probability of throwing greater than 4. Thank you everyone, this is it for today's mini test. I apologize for the mess of a video and the mini test that this was. I wish you best of luck solving, and I'll see you all next time. Bye!